given the formula for a function, we want to evaluate. So step one, we're going to replace the input variable in the formula with the value provided, and then we're going to calculate the result. So for example 6, we're going to be evaluating functions at specific values. We're going to evaluate the function f of x, which is equal to x squared plus 3x minus 4 of the following. Okay, so what we want to do is we're going to replace the x in the function with the specified value. The specified value is the value of 2. And so what we're going to do is we're going to replace each x variable with a 2. So in our function, x is the input. And so what we're doing now is replacing x to be 2. So now it becomes f of 2, which is equal to parentheses 2 squared plus 3 times parentheses times 2 minus 4, and then follow order of operations. Well, 2 squared is 4, plus 3 times 2 is 6 minus 4. 4 plus 6 is 10, minus 4 gives you a value of 6. So how do we write the following? Then we can say that f of 2 is equal to 6, where 6 is the output and 2 is the input. Okay, now in our next example, we're given the value of a as the input. So instead of writing x, we're going to replace it to be a. So now x becomes a. We're going to take a and then square it, plus 3 times the value of a minus 4. Well, when we square the a, we get a squared plus 3 times a, which is 3a minus 4. So a is the input, and now a squared plus 3a minus 4 is the output. So this entire thing now represents the output, where this a represents the input. Next, we have a plus h. Now a plus h we have as an input, so we're going to use that as an input, and we must use the distributive property. So the x now becomes a plus h. So we're replacing x to be parentheses a plus h, and then we're going to square it. Plus 3 times, what are we replacing x to be? A plus h minus 4. Now, in a plus h squared, we need to multiply this together as two binomials, which gives us a perfect square trinomial, which becomes a squared plus 2ah plus h squared. And then we're going to distribute the 3 to both of those terms to get plus 3a plus 3h, and then minus 4. Now, if there's any terms that we can combine here, then we would. But there aren't any terms for us to combine, so therefore this is the input and this becomes the output. Now in part B, what we want to do is we want to take the function when it has an input of a plus h, and then subtract the function when the input is a divided by h. So in this case, we apply the input values to the function more than once, and then perform algebraic operations on the result. So we have already found that f of a plus h gave us the following up here. The output is a squared plus 2ah plus h squared plus 3a plus 3h minus 4. And then we also found f of a in the previous example. And f of a, when a is the input, is a squared plus 3a minus 4. So what we're going to do now is, you see this f of a plus h. Okay, what that is this becomes the input. So f of a plus h is equal to this entire thing. And so instead of writing this now, we're going to write that in a group as a squared minus 2ah plus h squared plus 3a plus 3h minus 4. And then we're going to subtract what we have for f of a. Well, f of a is equal to a squared minus 3a minus 4, and then we're dividing the entire thing by h. Okay, now the next step is to then simplify. So we do not need to distribute anything here. So it becomes a squared plus 2ah plus h squared plus 3a plus 3h minus 4. And then here we need to distribute the minus sign. So that becomes minus a squared minus 3a, and then negative times a minus 4 gives you plus 4. And now we need to combine like terms. So when we combine like terms, okay, what it looks like here is that we have a squared minus a squared, so we can delete those. Then we have 2ah, and then we have an h squared, and then we have 3h. We have plus 3a and minus 3a, which we can delete. We have minus 4 and plus 4. So what's left in our numerator is 2ah plus h squared plus 3h divided by h. And now what's left in the numerator is that can we factor out something that they have in common? Well, each term has an h that we can factor out. So if we factor out the h, then what's left in the numerator is 2a plus h plus 3 divided by h. And so this h, now that we've factored out, we can simplify that. And so the remaining answer is 2a plus h plus 3.